Hello guys, welcome back to another exciting chemistry lessons by Adrenaline, the Bazooka Prophet. Now this particular video was asked by one of my students from India, and he said, "Sir, can you do a video for me on this topic, which is oxidizing and reducing agents using the oxidation number method?" And I assured him that I was going to do that, and today I'm doing it for everyone. Now, this particular topic is very unique and also very easy because it talks about redox, from the word redox. Now, look at it, redox. We should understand that the word redox is broken down into two, which is reduction and oxidation, in the sense that both reduction and oxidation, they occur simultaneously. Now, for better understanding, we're going to waste time actually. Now, we're going to be defining reduction and oxidation. Now, we should understand that oxidation, first of all, oxidation simply means the loss of electron. So, loss of electron is called what? Oxidation. Now, listen now. If there is a loss of electron for oxidation, there will be an increase in oxidation number. Take note, oxidation simply means an increase in oxidation number and also a loss of electron. The reverse is the case for reduction. In the case of reduction, it simply means the gain of electron, right? But a decrease in oxidation what? Number. Let us take a typical example. For example, if I'm having sodium here, give me sodium ion, for example. Now, take note. Any element in their own combined state have an oxidation number of 0. Any element in their own combined, meaning they are not in their compound form, it simply means that they have an oxidation number of 0. So meaning here is 0. When it has a charge, it is equal to that charge, which is +1. Now observe, now it is from 0 to +1, which means that there is an increase in oxidation number. And if there is an increase in oxidation number, it is simply an oxidation. But there is a loss of electron. For example, sodium has atomic number of 11. Both sodium 11. But the electron for sodium here is also 11. Why? Elements in their neutral state, meaning they have no charge, neutral state. The number of proton is equal to the number of electron. That is why when the atomic number here is 11, proton number is 11. Electron too will also be 11. Why? It is in its neutral state. But in the case of this one, it has a charge. And because it has a charge, which is positive, there will be a loss of one electron. So here becomes 11 is now equal to what now? 10, because it has lost one. So observe here, there is a loss of electron, but there is an increase in what now? Oxidation number. Is that clear? Now, in the case of chlorine molecule to chloride ion, now take note, we have said that elements in their uncombined state, right, or free element, they have an oxidation number of 0. Meaning here is 0, here is minus what? 1. Right? Here is 0, here is minus 1. So from 0 to minus 1 is simply a decrease in oxidation number. And if there is a decrease in oxidation number, it simply means that it is reduction. But there is a gain of electron. For example, if chlorine here, to give me chloride here, chlorine here is, both chlorine have atomic number of 17. The electron here, remember, it is neutral. Here will be 17. But Because this element here has a charge, and this charge is negative, it simply means there will be a gain. No melters, they gain. So if here was 70, it has gained 1. Don't confuse this sign. This sign here that means negative here means it is gaining. It is gaining. So if it is gaining here is 18. Is that clear? Now let us simply move straight away to other good examples here. Now please take note. Take note. Take note. Now we should also understand some basic things here. That when a species is being oxidized, right, it is simply undergoing what we call, it is simply a reducing what now agent. Take note, when you oxidize, you are a reducing agent, right? Because reducing agent, they are electron or donor. When they are substances that lose electrons. When they lose electrons, they become what now? Reduce. Sorry, they become oxidized in the process. That is why when you are undergoing oxidation, you are a reducing agent. When you are undergoing reduction, you are an oxidizing agent. Take note. When you are undergoing reduction, you are an oxidizing agent. Now take note. Oxidizing agent can also be called an oxidant. Take note, an oxidant. While a reducing agent can also be called what now? A reductant. Please take note of all this. Now, without wasting time, we are going to be taking our time to work on the next video. Please, we have established the fact of some certain regulations here. Now, we should understand some basic rules. Permit me, some basic rules here. Let me erase this part here. Now, please take note. Now, there are some basic rules which you should know. And some of the basic rules are when an element is in their uncombined state, uncombined form, right? Uncombined state, they have an oxidation number of 0. As you can see hydrogen molecule, bromine molecule, sodium atom, beryllium atom. All these elements you are seeing here has an oxidation number of 0 because they are in their free element or in their uncombined what now. Take note, uncombined state. For students preparing for NSAT exam, a NEET exam, JUPEB exam, WAEC, NECO exams, it is very paramount that you understand the rudiments. Is that clear? Now, oxygen in a compound has an oxidation number of -2, except in peroxides, like hydrogen peroxide, sodium peroxide, which is an higher oxide, where oxygen takes the valency of -1. Hydrogen is another typical example of element that when it combines with a non-melter, hydrogen, it takes +1. But when hydrogen combines with a melter, it becomes an hydride, having an oxidation number of -1. Now, while we continue from this aspect, we should understand some basic stuff here. Now, for example, sodium here and sodium ion. See it now? Sodium is in its uncombined state. The valency is 0. Sodium has a charge now. The valency here is +1. Now, that's something here now. You see now? You see the difference between the two of them? So, sodium here is equal to 0, but this sodium here is equal to what? +1, meaning the sum of the charge of the element is the algebraic sum of an atom for an element is equal to the what now? The charge. For example, if I'm having SO4 2-, the algebraic sum of this polyatomic ion here will be equal to the charge here, which is SO4 is equal to what now? Negative what now? 2, as you can see. Is that clear? Now, We are going to break this video into two for better understanding. Now, I'll just give just one example, then we can move to the next. Now, for example, from this question here is particularly a jam question. Now, look at the question here. I have to bring it out from questions. Now, look at it. We have zinc plus copper 2 ion to copper plus zinc. Now, please take note, using oxidation number method, I've told you before, elements in their own combined form have an oxidation number of 0, meaning here is 0, here is what? Now 0. Is that clear? Now, the charge of this one here is plus 2. Here is also what now? Let me erase here. Here is also what now? Plus 2. Now, look at it. From 0 here for zinc to plus 2. From plus 2 of copper here to 0. Now, look at it. From 0 to plus 2, there is an increase in oxidation number. From 0 to plus 2, meaning here is undergoing oxidation, right? And I've told you before, any species that can undergo oxidation is a reducing what now? Agent. In the case of this copper here, copper is from plus 2 to 0, meaning reduction. And any species that can undergo reduction is an oxidizing what? Agent. And take note, you know your reduced species, your oxidized species, your oxidizing agent, reducing agent from your reactant. Meaning in this case here now, zinc is oxidized, zinc is the reducing agent. Copper 2 ion here, not copper. Copper 2 ion here is undergoing reduction, and it is an oxidizing what now? Agent. Now, this is the part 1. Stay tuned for part 2 to get more insight. Thank you and God bless you.